we have a research program here that really looks at interspecies transmission, mostly of influenza viruses. So, really trying to understand what turns a virus that one day is a chicken or a swine virus and turns into a human virus. So, what are the mechanisms that control that, regulate it, and the other end of that, how do we stop it from happening? Most exciting thing about the area that I'm in is all about pandemic emergence, and so clearly we've lived that for the past 18 months or so. So there's I think a whole new realization of sort of the importance of these viruses, of the impact they can have, and really stresses how much we need better ways to vaccinate against them, better ways to treat them. And so, to me, I think that's the exciting thing here, is just the opportunities. I think, like probably any card-carrying virologist in the past 18 months, we have shifted to do a little bit of work with this SARS-CoV-2 coronavirus. So we have a containment facility here at St. Jude that we use. We have a lot of model systems that are necessary to study these viruses. And so, we've moved a lot of the resources and the expertise we had in flu into the coronavirus field to respond to this pandemic. And again, it comes back to a little bit what's gone really well with the COVID pandemic is a lot of these more platform technologies. Take, for example, the mRNA, right? So, these were technologies being developed, not really for this agent, for something else, but could rapidly move to respond to this pandemic. And I think that's, nanotechnology is right in line with that. So it's a platform in itself that can be really moved to respond to any number of threats. And so I think that's what I see the future of it. If you want more specific examples, mRNA vaccines are tremendously effective, but they're difficult to get inside cells. I think for a pandemic vaccine, they've been great, but if we're thinking about using that same technology for something like a flu vaccine that we have to get every year, are some of those side effects going to be a little bit too severe for that? So, are there better ways to get these existing mRNAs into a cell, for example? And so I think that's where nanotechnology has a role to play, and it's really going to push the field even further forward.